All right, so good morning. It is 8.1. So get out your notes. You should have some of this on your notes anyway, but just want to go through it briefly for you. Circles. So the definition of a circle, we've talked about this before. The definition of a circle is a given distance from a given point. Given distance, given point. Okay, so we have our keywords, all right? A radius. The radius is a segment from the center. Okay, so from the center to there. So CX is a radius, CR is a radius, CQ is a radius. All three of those are equal. That is the given distance. Okay, so that radius is given distance, all right? All radii of a circle are congruent. So we gotta remember that, those are important. A chord of a circle is what? It says it has its two endpoints where? The two endpoints are on the circle. So L and M are on the circle, Q and R are on the circle. So therefore, these are both chords. What is true about this chord is that it does not go through the center. This one does. So what does that make QR? Lisa? Yes, this makes it a diameter. Okay, so we've talked about that. A diameter is a chord that goes through the center. Okay, so these are all review terms. My suggestion is that you take a minute, make sure you have them all written down at the beginning of this section because they will all come in handy. All right, the next thing, we've talked about this, but I will review it. A secant line is a line that intersects a circle exactly 2 points. So if I were going to draw this for you, that would be a secant line. Notice it intersects 2 times. Okay, so a secant line, but it also, what does it form, by the way? What is this part of this? This part of this line is what? Chord. Good. So a secant line forms a chord every time because it's touching it twice. All right? Good. All right, so our first postulate from this chapter, from this section, is this, postulate 8.11. If a line intersects the interior of a circle, then it contains a chord of the circle. So, if a line intersects the interior, so if it goes through the middle, how many times is it going to touch the edge of the circle? So, let's review this. Okay, show this again for you. So I have my circle. This postulate, this chord postulate. As I draw a line and it goes into the circle, how many times does it touch the circle? Twice, and it forms a chord. Okay. Any questions on that? This is just a chord postulate. Just remember that it does form that. All right. The first theorem that we were going to talk about. If a radius. All right. So now go back to. We got to know what the word radius means. What does radius mean? It means it's the center point to the edge of the circle. All right. So we have a radius. OC is a radius. It says if a radius is perpendicular to a chord. So here's a chord. Here's a radius. If radius is perpendicular to a chord of a circle, then it bisects the chord. In other words, if this is 90 degrees, then these two are going to be what? They're going to be equal. Okay, so that is important to know. It's a very simple concept. Okay, so what you're going to see and the types of problems you're going to have to do. One of the types of problems they're going to have to do is they're going to say, oh, okay, so the whole chord is 15. What is from here to here? If this is perpendicular. So that would be 7.5. We're going to divide it in half. It's going to be 7.5. All right? So this simply says if it's perpendicular, then it bisects the chord. Okay? All right? We're not going to go through this whole proof, okay? We're going to skip through that. The next one is if a radius bisects a chord that is not a diameter, then it is what? Perpendicular. So it's the opposite. So you have one that says, okay, if it's perpendicular, it bisects. Now it says if it bisects the chord, then it's going to be perpendicular. Okay? So it's just the opposite. So when you start to think about these, it's going to come in handy, okay? So so your theorem 8.1.1 and 8.1.2 are opposites. Okay, so this one is 9, they're perpendicular. Bisects. And this one was what? If it bisects, then it is what? Good. Okay? So it's just the opposite. Alright, next theorem. 8.13. This is the line of in the plane of a circle that is perpendicular bisector of a chord contains the center. Alright, so this is a little bit different. And what we'll do is I'll show you here. Alright, so this one. So, I have my circle. It says it has a line. That is, think about that, perpendicular and bisects it. What are you going to know about this line that's perpendicular and bisects? It's going to have to do what? Go through the center. Okay, so it's all three of these theorems, three theorems deal with the same thing, perpendicular bisector. That just says that it's if they're perpendicular to bisects, if it's bisects is perpendicular, now it's saying, hey, if it bisects and perpendicular, then it has to go through the middle of the circle. It just has to do that. So let's look at an example. Find the diameter of a circle, 0 of O. So we want to find the diameter. Which is the diameter again? All the way across, it's 2r, right? So if we want to find the diameter of the circle, which is this whole thing, if OD, which is to here, okay, it's not the whole radius, it's 3. Well, how are you going to do that? So if this little distance is 3, first off, do you know what this is? Okay, it tells you what AB is, which is this whole distance right here, right? So what do we got that? So that's 8. So AB is 8. So if I had to break this down before we did it, okay, so if we're doing this problem, okay, so this whole thing is 8. From here to here, this is 3. Now, remember, if it bisects it, what do we know? So first off, what's this distance from here, A, to here? If this whole thing's 8, half of that is 4. So 3, 4, can we solve for this radius? If we solve for the radius, then what is the diameter? Well, the diameter is simply what? 2 times that. Okay, so what would we do? Well, A squared plus B squared, C squared, right angle, right? 3 squared plus 4 squared, C squared, 9 plus 16, C squared. C squared equals 25. Square root, C equals what? So what's my diameter going to be? Think about this. This whole thing's 5. So this is 5. So 5 plus 5 is? Very good. 10. All right, so let me show you their work, how they do it. They find AD, which is this distance here, and they find it to be 4. Then they put it into A squared plus B squared, give you 5, times it by 2 to get your answer. All right, so that's how you would find the diameter in this case. All right, next theorem. In congruent circles, or in same circles, okay? So if you have 2 circles, okay? So look at this one's a little bit different because it's dealing with 2 different circles. Okay, so the same circle or different circles. 2 chords, okay, are congruent. So this chord is congruent to this chord if they are equal distant from the center. Okay, so the chords are congruent if they're equal distant. So 8.14, okay, is simply this. The chords are congruent if they're equal distant. So here's a good example. give you a second to write that down. Ian's singing in the background. Thank you, Ian. All right. All right, everybody got that written down? Here you go. So let's do this problem together. So we have our problem. Okay, so now notice that it says Alright, so here we go. It says find AB and GF. We want to find this distance if CD is congruent to HI. So we know these are going to be equal, they're radiuses, so that's the computer radius. CE is equal to HJ. So this is going to be equal to this. So that means that's going to be true. So how would we solve it? AB equals GF. So here we go. 5y minus 3 equals 2y plus 9. Subtract, add 3 to both sides, add 3. That cancels. You're left with 5y equals 2y plus 12 minus 2y, right? Minus 2y. And once you do that, cancel. 3y equals 12. Divide by 3, divide by 3. Y is 4. Take your y and plug it back in. 2 times 4 is 2 times 4 is 8. 8 plus 9 is 17. So your answer is 17. So let's show you the work. Okay, so they're equal. We set them equal to each other. We get to 4. So we got that. Now, you plug it back in. Then plug it into 5. 5 times 4 is 20. 20 minus 3 is 17. There you go. You can check your work. Let's try another one. All right. So let's look at this one together. They want us to find CH and HB. They want us to find those two things once they give you this information. AD is and GE are 10. They're both equal. So we got to find them. First off, CE is 13. So can I ask you a question? What would HB, what would CB be? 13. Good. 13. So this is 13. So we have to figure out what CH is and then just subtract that from 13 and give you this, right? Okay, so what are we going to do? So if this is, let's think about this for a second. If this whole thing is 10 and it's being cut by a right angle, that means this is going to be what? 5. Good, 5. So if this is 5 and this is 13, how do we solve? What do we use? It's a right triangle. What formula do we use when we have a right triangle? Pythagorean theorem. Good. So, we found our 5, and they set it up. CJ is going to be 13 squared plus 5 squared equals 144 divided by square root of that is 12. Okay, so what they did is they took this right here and they squared it. Okay, took the square root of it. They had 13 minus the 5 squared, and then this is what you're solving for, and that's where you get 12. Okay, so when you get 12, now what? Now remember, how do we find, so CH is 12, CH is 12, what is HB? Remember, CB is 13, so this is 12, this whole thing's 13, what's left? Good, 1, the answer is 1. So let's see what we got, and there you go. There you have it. Okay, so those are the kind of problems you're going to be doing. So the main things you're going to remember, 8.1, 8.2, these different theorems, 8.1.1, 8.1.2, 8.1.3, all deal with perpendicular and bisectors. 8.4 deals with if it's equidistant If it's the same size chord, then it's the same distance from the center. Okay, so that's something you got to remember. Those are the four theorems we're going to learn in 8.1. All right, good luck. I'll give an email with your homework in. All right.